If someone told a 4-year-old boy that his love of chess would lead him to reimagine the limits of human knowledge, would he believe them? This is the story of Demis Hassabis, a prodigy who started with a board and pieces and ended up redefining science modern. Demis was born in 1976 in London, United Kingdom, at a time when the world was still trying to understand what artificial intelligence meant. From an early age, his mind seemed to operate differently. At 4 years old, he not only learned to play chess, he fell in love with the strategy, the logic, and the beauty of the patterns the game revealed. For many, chess is a pastime or a challenge. For Demis, it was a window into the workings of the human mind. At the age of 9, while leading the England under-11 chess team, he began asking questions that most adults would never consider. How do our minds manage to create such complex strategies? What makes our decisions so instinctive? And, perhaps more importantly, would it be possible to teach something non-human to think like us? It was around this time that young Demis found something that seemed magical, one of the first chess computers, the Fidelity Chess Challenger. The little machine was rudimentary by today's standards, but for Demis it was a glimpse of the future. He wasn't content with just playing against her. Instead, he became obsessed with the idea that someone somewhere had managed to program a piece of plastic to challenge a human. How was this possible? He needed to understand. While other boys his age dreamed of football or outdoor adventures, Demis immersed himself in books about programming and artificial intelligence. At age 11, he wrote his first AI program on his trusty Amiga 500, a computer that many would consider limited. The program, a basic board game, was rudimentary but successful. He managed to defeat his younger brother, then 5 years old. The triumph, although modest, lit a spark that would never go out. But his journey was not linear. Like any great mind, he faced doubts. Why should I care about machines that think, he asked himself. The world was already so vast, so full of real mysteries, yet something inside him told him there was something deeper to discover, something that went beyond games or intellectual curiosity. Throughout his adolescence, Demis realized that the skills he was developing with chess and programming could be applied to something much bigger. Chess strategy was, after all, a microcosm of life itself. Every move we make creates new possibilities and new challenges. And AI, he intuited, could be the tool for understanding these patterns on a much larger scale. Demis completed his university studies in London with an insatiable hunger for knowledge and a clear vision. Artificial intelligence was not just a matter of programming, it was a matter of understanding the very essence of human thought. This vision led him to venture into areas as diverse as neuroscience and game design, each step reinforcing his belief that he was on the right path. But what happens when a young prodigy realizes his dreams are bigger than himself? When the desire to understand human thinking leads you to imagine a machine that not only follows instructions, but can also learn, create, and innovate. It is at this point that the story of Demis Hassabis begins to intertwine with the history of modern science, and this is where we leave our protagonist, on the brink of turning his passion into a revolution. As he walked forward, one question haunted him. If I can teach a machine to think, will it be able to answer the questions that even humans can't answer? This doubt, as instigating as it was disturbing, led him to found one of the most innovative laboratories in the world, and that's exactly where the next part of this journey begins. Imagine creating something so revolutionary that it would change the way we understand intelligence and learning. For Demis Hassabis, this wasn't just a dream. It was the next logical step on his journey. And it all started with something many would consider a pastime: the games. By the early 2000s, Demis had already accumulated a wealth of knowledge in neuroscience, programming, and game design. He understood something that few did at the time. Games are not just entertainment. They are closed systems with clear rules, well-defined challenges, and measurable results. In other words, they are the perfect training ground for artificial intelligence. In 2010, he founded DeepMind with a bold mission: to build artificial general intelligence, AGI. This wasn't just a machine programmed to solve specific problems like calculating numbers or organizing data. It was something bigger, a machine that could learn anything like a human being and apply that learning to solve complex challenges. To test their ideas, Demis and his team started with classic games like Pong, Space Invaders, and Breakout. To many, it seemed like a waste of talent. After all, why spend precious resources training a machine to play video games? But for Demis, these games were microcosms of the real world. They involved strategy, real-time decision-making, and adapting to dynamic environments. And most of all, they offered instant feedback. You win or you lose. There is no gray area. What happened next was impressive. In 2013, DeepMind created an AI system that not only played these games, but also taught itself how to play them, just by watching the screen and receiving rewards for performance. The moment when AI discovered on its own how to create strategic tunnels in Breakout was a watershed moment. For the first time, a machine was demonstrating creativity and intuition in a similar way to a human. But that was just the beginning. The big turning point came in 2016 with the launch of AlphaGo, a system designed to play Go, one of the most complex games ever invented by humanity. To give you an idea, the number of possible configurations in a game of Go is greater than the number of atoms in the universe. For centuries, gaming was considered the ultimate challenge for artificial intelligence, a territory where only brilliant humans could thrive. AlphaGo changed everything. In a historic match, he defeated world champion Lee Sedol 4-1. But the most notable thing was not the victory. That's how AlphaGo won. In the second game of the series, the machine made a move that left experts perplexed. Play 37. It was a move so unexpected, so counterintuitive, that commentators initially believed it was a mistake. But 100 moves later, it became clear that that move had been the key to victory. A computer didn't just play Go, he had created a new way of thinking about the game. That moment resonated around the world. It wasn't just about games anymore. It was about what it meant for humanity. If a machine could learn, create, and innovate something as complex as Go, what else could it do? Solve scientific problems? Discover cures for diseases? Predict climate change? As DeepMind gained notoriety, Demis continued to reinforce the central idea driving its mission. Artificial intelligence is not just a technical tool, it is a reflection of human potential. Games were just the starting point, a way to train these machines to take on even greater challenges. And this is where the story takes on a personal tone. Think about your own life. How many times have you faced challenges that seemed impossible? How many times have you wished you had a way to predict the right next move? The story of AlphaGo reminds us that, even in seemingly unreachable scenarios, there is a solution, a strategy, a path. Artificial intelligence is not just about machines. It's about discovering the best of ourselves and expanding our limits. Demis and his team proved that gaming was a valuable testing ground, but now they were ready for the next level. They wanted to take the learning and creativity they developed in games and apply it to the deeper challenges of science and society. And that's exactly where the next challenge comes in. If you could unlock life's most intimate secrets, what would you do with that knowledge? That was the question Demis Hassabis and his team faced when they decided to tackle one of biology's greatest mysteries, protein folding. Proteins are the fundamental machines of life. They play critical roles in virtually every biological process. They contract muscles, transport oxygen, fight disease, and more. But what makes a protein capable of performing these functions is its three-dimensional shape. And here's the challenge: how to predict the shape of a protein, based only on its amino acid sequence. For 50 years, this question has intrigued scientists. Solving this wasn't just an intellectual exercise. It was the key to advances in areas like drug discovery, disease treatment, and even biotechnology. This question, known as the protein folding problem, was a monumental challenge. A single error in the folding process can mean the difference between life and death for a cell. Even worse, predicting a protein's shape manually can take years of hard work in the lab. There didn't seem to be a practical solution, or was there? That's when the DeepMind team, led by Demis, decided to try something bold. They envisioned a system that not only analyzed biological data, but learned from it, exploring hidden patterns that elude even the most experienced scientists. This is how AlphaFold was born. Initially, expectations were moderate. After all, no one believed that an algorithm could outperform experimental methods refined over decades. However, in 2018, AlphaFold surprised everyone by winning the International CASP Critical Assessment of Structure Prediction competition, a milestone in computational biology. But that was just the beginning. The real revolution came in 2020 when the AlphaFold 2 arrived on the scene. Combining deep learning, physics models, and advanced artificial intelligence, the system has achieved a level of accuracy that many believed was impossible. He could predict protein structures with atomic precision, achieving average errors of less than an angstrom, the equivalent of the width of an atom. What previously took months or years in the laboratory could now be done in a matter of hours. But how exactly was this possible? The secret was in the way AlphaFold handled the problem. Instead of trying to simulate the exact physical process of folding, it analyzed huge amounts of data on known proteins to find patterns. It was like teaching a machine to understand the language of proteins and, from that, predict how they communicate in their final form. And then came the question that changed everything. If we can predict the structure of a protein, what else can we discover about life? This was not just a victory for science, it was a redefinition of what was possible. In a single year, AlphaFold predicted structures for every protein known to science, more than 200 million. This information was made available free of charge, democratizing access to knowledge and accelerating research across the world. Think about the impact of this. Scientists working on medicines for rare diseases now had ready access to information that might have taken years to obtain. Researchers trying to combat cancer, Alzheimer's, or even pandemics like COVID-19 have gained a critical advantage. AlphaFold wasn't just a tool, it was a multiplier of human efforts. And here's the real surprise. AlphaFold did more than solve the problem of protein folding. He opened the doors to the future. Now, scientists were beginning to explore how to use AI to model dynamic interactions between proteins, predict how they behave in different conditions, and even simulate entire biological systems. What was once the domain of science fiction now seemed within our reach. But this story is not just about machines or algorithms. It's about what it means to be human. Demis has always highlighted that artificial intelligence does not replace human creativity or passion, it amplifies them. He believes AlphaFold is just the beginning, proof that with the right tools we can tackle the most complex challenges and make discoveries that previously seemed unattainable. And now I ask you, if a machine can unlock the secrets of proteins, what else could we achieve if we combine this technology with human imagination? What does the future hold when we start using these tools to explore the mysteries of the universe? Imagine a world where medical discoveries don't take decades but weeks, where treatments for incurable diseases emerge as quickly as needed. It sounds like science fiction, but we're closer to that than you think. And it all started with the ambition to use intelligence artificial not just to understand the world, but to transform it. After the success of AlphaFold, it became clear that AI had the power to revolutionize science. For Demis Hassabis and his team at DeepMind, the question was obvious: what would be the next challenge? If AlphaFold was able to predict protein structures with near-perfect accuracy, the natural next step was to explore how these proteins interact, and more importantly, how this understanding could be used to improve lives. Here comes one of the most promising applications of AI, drug discovery. The traditional process of developing new drugs is long, expensive, and often ineffective. It is estimated that on average, taking a drug from concept to market costs more than $2 billion and can take up to 15 years. It is a path full of uncertainties, where the majority of tested compounds never become viable products. But what if it were possible to speed up this entire process? AlphaFold 3, the most recent evolution of the system, has begun to open new doors. Unlike its predecessor, which focused on predicting static structures, AlphaFold 3 is designed to model dynamic interactions between proteins and other molecules. This innovation made it possible to simulate not only how proteins fold, but how they interact with DNA, RNA, and small compounds, crucial information for creating effective medicines. Consider a scenario where researchers are trying to develop a drug to combat a rare type of cancer. Traditionally, they would have to spend months, even years, testing combinations of molecules in laboratories. With AlphaFold, these tests can be performed virtually in a matter of days. AI helps quickly identify which compounds are most likely to be successful, saving time and resources, and the impact of this is already being felt. For example, in a recent study, researchers used AlphaFold to engineer enzymes that can efficiently degrade plastics. This may seem like an environmental goal, but the technology is applicable to human diseases. The same approach could be used to engineer enzymes that combat rare genetic diseases. On another front, research teams are using the system to understand how viruses interact with human cells, an application with clear implications for future pandemics. But here's something you might not expect. It's not just large institutions that are benefiting from AlphaFold. Thanks to DeepMind's decision to make AlphaFold predictions publicly accessible, scientists around the world, including at smaller universities and developing countries, now have access to tools that were previously exclusive to cutting-edge laboratories. This democratized scientific research, allowing brilliant minds everywhere to contribute to solving global problems. And while the immediate focus is on medical applications, AlphaFold's potential goes much further. Imagine creating new materials with extraordinary properties, such as lighter, stronger fabrics, or more efficient batteries. Or perhaps discover completely new ways to store and generate clean energy. AlphaFold is more than a scientific tool. It is a catalyst for innovation at all levels. But there is an important point for reflection here. How far should we go? As AI advances, complex ethical questions arise. Who should have access to these tools? For Demis Hassabis, these are not secondary issues. He believes that as AI becomes more powerful, it is essential to build governance and accountability mechanisms that ensure the benefits are widely distributed. Now, let me pause for you to reflect. How many times in human history have we had the opportunity to radically transform our future? We are in a unique moment where technology allows us to accelerate discoveries and save lives on an unprecedented scale. But with great power comes great responsibility. How would you use this power? If we've come this far, what's next? This is the question that defines not only the history of artificial intelligence, but also the future of our species. As Demis Hassabis and DeepMind's work progresses, one thing is becoming clear. Artificial intelligence is not just a tool, it is a reflection of who we are as humanity. Every advance, from games that taught machines to think to solving the problem of protein folding, leads us to an inescapable conclusion. AI has the potential to amplify the best in us. But here's the big question. How are we going to use this technology? AlphaFold has proven that we can use AI to solve monumental scientific challenges, accelerate discoveries, and democratize access to knowledge. But there are also risks. Such powerful technology can be used for destructive purposes, deepening inequalities or prioritizing the interests of the few to the detriment of the many. Demis Hassabis often highlights that AI does not replace human creativity or passion. It serves as an amplifier. This means that it is up to us to decide how this technology will be shaped. Every algorithm created, every problem solved, and every system deployed reflects the values of the people who built them. And that brings us to the final point of this journey, the role of humanity. We are at a historic inflection point. Just as fire and electricity transform societies, AI is transforming ours. The difference is that, this time, the speed of change is overwhelming. What took centuries now happens in years, and the impact is felt in all spheres: health, environment, education, science, and even in our daily lives. Think about it. If AI can predict the shape of proteins, could it help understand human behavior in ways we've never imagined? Can it find solutions to social conflicts, improve education systems, or even create a more sustainable future? The answer is within our reach, but it requires something fundamental: collaboration. No individual or institution can solve major global challenges alone. AI, as a tool for transformation, requires us to work together: scientists, governments, businesses, civil society, and you. Yes, you. Every time you choose to learn more about technology, question its implications, or share stories like this, you are shaping the future. And this brings us to a point of conclusion. If AlphaFold represents the beginning of a new scientific era, what comes next will be even more challenging and transformative. We're just scratching the surface of what artificial intelligence can do. Modeling dynamic interactions, discovering medicines in weeks, predicting behaviors in complex systems, all of this is already a reality under construction. But the true power of AI is not in the technology itself. It's in the way we choose to use it to create a better world. Now I want to invite you to be part of this journey. Subscribe to the channel to continue exploring how technology is transforming our world. Like this video so more people can discover stories like this, and share your ideas in the comments. How do you think we can use AI to solve humanity's biggest challenges? Your reflections can inspire others to think differently and contribute to a more collaborative and innovative future. Finally, I want to thank you, who made it this far, for dedicating your time to this story. Stories like Demis Hassabis are not just about innovation, they are about human potential. And this channel exists to explore exactly that, how we can come together to face challenges, create solutions, and imagine a future worth building. The next video will dive even deeper into how AI is being applied in areas you may have never considered, so stay tuned. Until then, remember, the future is being written now, and each of us has a crucial role in that story. Thanks for being here. Let's continue building together.